Scientific notation expresses a number in the form of a coefficient times 10 to some power. So when we were looking at some examples where we're either going from scientific notation to standard form or standard form to scientific notation, when the number is expanded, such as in example 1, we are in standard form. Our first step to write it in scientific notation is to create a coefficient that's between 1 and 10 but less than 10. So if we were to place our decimal anywhere between these numbers to create a number that's between 1 and 10, our decimal would go between 4 and 9, which gives us a coefficient of 4.9 times 10 to some power. The way that we figure out what our new exponent should be is by counting the distance in place value from our new decimal to our original decimal. In a whole number, the decimal always comes to the right of that number. So we are 1, 2, 3, 4, 5, 6, 7, 8, 9 places away, which gives us an exponent of 9. Examples 2, 3, and 4 are written in scientific notation, so we need to write them in standard form. We're looking at our coefficient, 5.5, and our exponent tells us the direction in which to move. A negative exponent signifies a small decimal number. So we are going from our original decimal to figure out what our new decimal placement would be by moving 3 spaces to the left. 1, 2, 3. We would then fill in those empty spaces with zeros. So our standard form for this number would be 0.0055. Remember from last class, anything to the 0 power is 1. So in example 3, we have 3.2 times 1, which gives us 3.2. And finally, in example 4, a positive exponent tells us that we must move our decimal 9 places, or however many places that exponent would be, to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9. And we would then fill in those places with zeros. Be sure to write out your number and put your commas every 3 numbers from the left. Remember, that exponent does not tell us how many zeros to fill in. It tells us how many places to move our decimal. We are changing the place value of the number, not the number itself. So we have 4,900,000,000 as our final answer. In today's lesson, we are converting numbers. In today's lesson, we are dividing 2 numbers that are written in scientific notation. Please take a moment to write these rules down in the notes section of your handout. Let's look at an example where we would follow the rules that you just wrote down. Step 1 is to divide out the coefficients. When we are dividing 2 numbers that are in scientific notation, we are dividing the coefficients and dividing the bases of 10 using the laws of exponents that we've learned. 8 divided by 2 gives us 4, and 10 to the 6 divided by 10 to the third, we would apply the quotient rule, which tells us to subtract our exponents, which would give us 10 to the 6 minus 3, which is 10 to the third. So our final answer is 4 times 10 to the third power. We would then check and see if our final answer has a coefficient that's between 1 and 10, which it does, so we are done with this example. The next example that we'll look at, we will be following the same steps, we just have different values for our coefficients. Another way to set up division is by writing out a fraction. 5.76 times 10 to the second power divided by 4.55 times 10 to the negative fourth power. As our first step, we would use our calculator to divide 5.76 by 4.55. We'll round our answer to the nearest hundredth, 2 decimal places. We have 1.27 times 10 to some power. So remember, for the quotient rule, we are subtracting the numerator by the denominator. So we have 2 minus a negative 4, and a negative times a negative gives us positive. So we have 2 plus 4, which gives us an exponent of positive 6. Our last step is to make sure that our coefficient is between 1 and 10, which it is. So we have our final answer. 1.27 times 10 to the 6th power. Try this example on your own before we go over it together. Facebook receives approximately 839 million likes per year on posts, pictures, etc. If a company has approximately 7,560,000 fans, about how many likes is each user responsible for each year? So one hint for this problem is to write out 839 million in standard form before you convert it to scientific notation. Be sure to convert 7,560,000 into scientific notation as well to apply the rules that we've learned in the previous examples. I have expanded 839 million into scientific notation. So to figure out how many likes each user is responsible for each year, we must divide the number of likes by the number of fans. Before I do this, I'm going to convert my numbers into scientific notation. Now I can divide each coefficient, 8.38, divided by 7.56. Be sure to round your answer to the nearest hundredth. 1.11 times 10, after dividing out 10 to the 8th and 10 to the 6th, we have 10 to the 2nd power. Our coefficient is between 1 and 10, less than 10, so we have completed our last step. Remember, your coefficient has to be between 1 and 10, less than 10, to be in proper scientific notation. So if you look at example 1, 234.6 times 10 to the 9th, our coefficient is not between 1 and 10. If we were to move this decimal 2 place values to the left, we would have 2.346, which is now a number that's between 1 and 10. However, because we have changed our place value, we must also change our exponent. Since we moved 2 places to the left, making a smaller coefficient, we must add 2 place values, or 2, to our exponent to keep this balanced. 9 plus 2 gives us an exponent of 11. 33 times 10 to the negative third. If we moved our decimal one place to the left, we would have a number that is between 1 and 10. 3.3 times 10. So since we've moved 1 to the left, we must add 1 to our exponent. Negative 3 plus 1 gives us a negative 2. They're still the same number. They're equivalent. The third example, we have a number that is less than 10. Since it's less than 10, we would have to move one place to the right to create a coefficient between 1 and 10. We now have 6.3 times 10 to some power. Since we're moving to the right to make this number larger, we will now take away 1 from our exponent to keep this equation balanced. Negative 1 plus 1 gives us an exponent of 0. And there you have it.